Hello, viewers. In today's session, we are going to discuss a very important and interesting problem, right? And here we have to find the remainder when 32 raised to 32 raised to 98 is divided by 7. We have already solved these kind of problems in our earlier videos, and here once again we'll quickly see the concepts which are going to be used to solve this problem. So let us first take this number as y, right? So we have y is equal to 32 raised to 32 raised to 98. And we have to find the remainder when this number y is divided by 7, right? So let us first quickly the concept which is going to be used to solve this problem. See, if we have a number say 1 plus x raised to n, then this number can be expressed as 1 plus x times lambda, right? Where this n is a positive integer and this n is also a positive integer, right? And similarly, if we have a number say x minus 1 raised to n, then x minus 1 raised to n can be expressed as 1 plus x times say mu when this n is an even number, right? So this n is even positive integer, and when x minus 1 raised to n and n is odd number, that is odd integer, positive integer, then x minus 1 raised to n can be written as minus 1 plus x times some number say L, right? So L is also a positive integer, right? So we have here three cases. In the first case, 1 plus x raised to n can be written as 1 plus x times lambda, where lambda is some positive integer and n is also a positive integer. And when we have x minus 1 raised to n, then this number can be written as 1 plus x times mu, where mu is some positive integer, and this form is valid when n is even, right? But when we have x minus 1 raised to n and n is an odd positive integer, then x minus 1 raised to n can be written as minus 1 plus x times L, where L is some positive integer. So now let us apply these concepts to this problem. So what we will do here, we'll first take this number, that is 32 raised to 98, right? Now 32 raised to 98 can be written as 2 raised to 5, because 32 can be written as 2 raised to 5 and here we have 98. So we can now write 2 raised to 5 times 98, right? So we can write 2 raised to 5 times 98 is 490, right? And now this 2 can be written as 3 minus 1, right? And here we have the exponent 490. Now this is a positive integer, right? And we have 3 minus 1 raised to 490. So we can now apply this rule, because here n is even and 490 is an even positive integer. So 3 minus 1 raised to 490 can be written as 1 plus x times mu, and x is 3. So we can now write 3 times mu, where mu is some positive integer. So 32 raised to 98 is equal to 1 plus 3 times mu, right? So now let us come to this number y. So y can now be written as 32 raised to 32 raised to 98, and 32 raised to 98 can be replaced by 1 plus 3 times mu. So now let us rewrite this 32 as 2 raised to 5, and here we have the power, that is 1 plus 3 times mu, right? So by the laws of exponents, let us multiply 1 plus 3 mu by 5. So we have 2 raised to 5 times 1 plus 3 times mu. So now y can be written as 2 raised to 5 times 1 is 5, and here we have 5 threes are 15, that is 15 mu. So now let us split this 5 as 3 plus 2, right? So we have 2 raised to, here we have 15 mu, and this 5 can be written as 3 plus 2. So now we can group these two numbers together, right? So we can now write y is equal to 2 raised to 15 mu plus 3, and then we can write 2 raised to 2, and here we have 2 square. So here we have again used the laws of exponents, and because the base is same here, so we can write 2 raised to 15 mu plus 3, and here we have 2 square, right? Now this 2 square can be written as 4, so we can write it here. So 4, then we have 2 raised to 15 mu plus 3. Now let us write or let us take 3 common here. 15 mu plus 3, we can take 3 common. So we have 3 times 5 mu plus 1, right? And again, using the laws of exponents, we can write it as 2 raised to 3. And then here we have 5 mu plus 1, right? Okay, now we have 4, then 2 cube can be written as 8. So we have 8 raised to 5 mu plus 1, right? Okay, now we can write 4, then this 8 can be written as 7, 7 plus 1, and then we have here 5 mu plus 1. So now let us compare this term with this one, right? So here we have y is equal to 4 times, here 7 plus 1 can be written as 1 plus 7 raised to 5 mu plus 1. So now if we compare this term with this one, then our x is 7, right? And our n is 5 mu plus 1. So now with the help of this result, we can write y is equal to 4 times here 1 plus 7 raised to 5 mu plus 1 can be written as 1 plus x times lambda. So we have 1 plus x is 7, and we can introduce here lambda, right? So now y can be written as 4 times 1 plus 7 times lambda, where lambda is some positive integer. So we can now write, we can multiply these two terms with 4. So we have 4 plus 28 times lambda. Now let us consider this term, that is 28 lambda. So we can write y as 4 plus 7 times 4 lambda, right? Because 28 lambda can be written as 7 times 4 lambda. And now here we can take this 4 lambda as some other positive integer, say L, right? So we can now have y is equal to 4 plus 7 times L, right? And this expression shows that when y is divided by this number 7, then the remainder r is 4. So now we conclude that this number y, which is 32 raised to 32 raised to 98, is divided by 7, then our remainder is 4, right? We can also write this expression as y minus 4 over 7 is equal to L, right? So this is how, by making use of these results, we can solve these kind of problems very easily.